Good morning. Welcome to our science class of class 8th. Today we are going to start a new chapter number 4, that is metals and nonmetals. So let us know about that what are metals and what are nonmetals and what are their properties. In this chapter we are going to cover the different topics. The topics are as follows that we are going to cover in this chapter one by one. Topics are: first topic is metal and non-metal. Second is physical properties of metals and non-metals. Third is chemical properties of metals and non-metals. And fourth one is uses of metals and non-metals. So we are going to discuss about all the topics one by one. Before that, firstly we will know about that what are metals. So firstly we are going to know that what are metals. But before that, just I am going to introduce about this chapter. You have seen the different types of objects. We are observing the different types of object around us, and they can be categorized into two types of elements, that is metals or non-metals. Your books, clothes, pencil, water bottle, bag, table, door, all are the examples of non-metals. Therefore, it is important to know the properties of metals and non-metals. We associate metals with hard, shiny objects and non-metals with dull, light objects. These are nothing but the physical properties of metals and non-metals, but we know about their properties. Now let's find about the physical properties of metals and non-metals. So firstly we will know about that what are the physical properties of the metals. But before that, firstly we will know that what is metal. So how we will define that what is metal? Metal is an element that can form the positive ions by losing the electrons that is found in its valence shell. Means the number of electron that is present in its outermost shell is known as valence electron. And metals are the elements that have the tendency to lose that electrons. They can easily lose that electrons to form the electropositive ions. By losing the electrons, they form the positive ions, that is known as positively charged ions are formed by this way, and that is known as cations. So they form the electropositive ions by losing the electrons, and they generally have 1, 2 or 3 electrons in its outermost shell. Means that the number of electrons that is found in its outermost shell is known as valence electrons. So they have mainly 1, 2 or 3 valence electrons in their outermost shell. So they can lose 1, 2 or 3 electrons very easily to form the electropositive ions. So they have the tendency, so we can say that they have the tendency to form the electropositive ions. This is one of the most important feature of the metals. There are some examples of metals also. For example, first one, that is sodium. The symbol of sodium is Na. Second one is potassium. The symbol of potassium is K. Third one is calcium. The symbol of calcium is Ca. There are so many examples of the metals in which some examples are given here, and the symbol is also given. So we must know about that what are the examples and what are the symbol of these metals. Now next is about the occurrence of metal. Now we are going to know about that how these metals are found in nature. These metals are found in both in free state as well as in combined state. Free state is also known as native state. Means the metals which are very less reactive, they only found in free state in nature. There are some examples of the metals which is found in free state also. For example, platinum, gold, silver. These are the certain examples of the metals that is found in its free state or native state. But there are some metals which are reactive. Except these three metals, The other metals which are reactive, they are mainly found in their combined state. Means they are found in, they occur in combined state in the earth crust. Means they are present in the form of their oxides, in the form of their sulfides, in the form of their sulfates, carbonates, nitrates and chlorides. So they are found in combined state in nature. Now we must know about that what are metalloids. So there are certain elements whose properties are intermediate between that of metals and non-metals, means that they shown the properties of, there are some elements that shows the properties of both metal as well as non-metals, so that's why they are known as metalloids. So the elements, we can say that the elements which have the property of both metal and non-metals are known as, they possess the property of both metals and non-metals are known as metalloids. There are some examples also given here. For example, germanium, arsenic, silicon. These are the examples of the metalloids. Next, we will know about that what are the physical properties of metals and non-metals. Now we are going to know about that what are the physical properties. Firstly, we will know about that what are the physical properties of metals. Later on in our next part of this chapter, we will know about that what are the physical properties of non-metals. So firstly, we are going to know about that what are the physical properties of metals. So let us know about that what are the physical property. Physical property, the first is physical state. So we are just going to know about that how it is found at the room temperature. Room temperatures, the metals are generally found in solid state. Means mostly the metals are found in solid state at room temperature. You are knowing that there are three states of metal: solid, liquid and gas. There are three states of matter. These three states are solid state, liquid state and gaseous state. So the metals are generally found in its solid state at the room temperature, but there are some exceptions also. The exceptions are mainly mercury and gallium. These are the two exceptional cases, and these are the metals that is mainly found in liquid state at the room temperature. So this is about the physical state of the metal. Next is about the hardness. Now we are going to know that metals are hard or not. Metals are generally hard. Metals are generally hard, but there are some metals, means there is some exception here also. There are some metals, for example sodium and potassium are the example of the two metals which are soft, and that's why you can cut it easily with a knife. You can cut it easily with a knife. These are the soft, these are the examples of the metals which are very soft. So metals, so we can say that mostly the metals are hard, but there are some exception also. For example, sodium and potassium are the examples of the metals that are soft and you can cut easily with a knife. Now next is about the lecture. Lecture means sign. Lecture means sign. The metals generally have the sign in their pure state. And the property, this property we can say the property of shining of metals is known as metallic luster. So the metals generally have the metallic luster in the pure state. This metallic luster they possess because the light that falls on its surface gets reflect, and due to the means instead of absorbing the light they reflect the light, and due to this property they have the metallic luster. So metals generally have the metallic luster. Next is about the next physical property is about the melting point and boiling point. Now we are just going to know about that metals have the high melting point or the low melting point. The metals generally have the high melting point and the high boiling point, but there are some examples of the metals. For example, tungsten is one of the example of the metal which have the high melting point, means it melts at high temperature. So that's why that tungsten wire is used as a filament of a bulb, because it has very high melting points. So it cannot melt at very high temperature, so it is used as a filament of a bulb. Sodium and potassium are the examples of the metals that have very low melting point. These are the examples of the metals. They have the very low melting point, and mercury is one of the example of the metal that have the low melting point. So this is about the melting point and boiling point of the metals. Next physical property that they possess is the malleability. So first of all, we know that what is malleability. Malleability means this is one of the property that is possessed by the metals, and by the virtue of which they can be beaten into thin sheets. Means that when we hammered it, it can easily be converted into thin sheets or foils. And this property of conversion of metal into thin sheets or foils is known as malleability. There are some examples of the best malleable metals also. For example, gold and silver. Gold and silver are the example of the best malleable metals. So you can easily convert it into the thin sheets or the foils by its hammering. Next property is about the ductility. So we are just going to know about that. What is ductility? Ductility is that property by the virtue of which they can be drawn into thin wires. Means that you are able to convert the metals. Means the metals are able to be converted into thin wires, and this property is known as ductility. So that's why there are some examples like copper. Copper wire we are using because copper is a metal, and it has it possesses this property, that is ductility. So there are some examples of the metals which are highly ductile. For example, gold, silver, copper, iron. These are the examples of the highly ductile metals. So we have known that what is this ductility property. Means this is a property by which the metals can be drawn into wires, and this property is known as ductility. Next we are going to know about that what is tensile strength. So firstly we'll know that what is tensile strength. What is the meaning of the tensile strength? Tensile strength means they have the high tensile strength. Means metals generally have the high tensile strength. It means that they can hold the large weights. And without breaking. You can hold the large weights on that and it cannot break. So this property is known as tensile strength. But there are some exception also. The exceptional cases, zinc and arsenic. Zinc and arsenic are the metals which do not possess this tensile strength. Next is about the conductivity. Now we are going to know about that. What is conductivity? We can say that metals are generally the good conductor of heat and electricity. Conductivity means they allow the heat and electricity to pass through them. So they are mostly the good conductors of heat and electricity. In which one of the example of the metal that I am giving you is the silver. Silver is the best conductor of electricity, and after silver the second number is of copper, third number is of gold, and fourth number is of aluminum, and fifth number is of tungsten. So these are the examples of the metals that are the best conductor of electricity, in which we will give the first number to that of silver, then after the number of copper, then third number is of gold, fourth number is of aluminum, and fifth number is of tungsten. So these are the examples of the metals that allows the electricity to pass through it. Now next physical property that the metal possesses, sonorous. Metals are sonorous. Means they produce a ringing sound. Means when you struck it with a hard object, it mainly produces a ringing sound, and this property is known as sonority property, and the metals are sonorous. But there is some exceptional case here also. That exceptional case is sodium and potassium. Sodium and potassium are the example of the metals that are not sonorous. Means when you struck it with a hard object, it do not produce any kind of ringing sound. So they are non-sonorous metals, and this is the exceptional case. Next we are going to study about the chemical properties. So this is about the physical property of the metal. Now we are going to discuss about the chemical properties of the metals one by one. So firstly in this we are going to know about the electronic configuration. So first of all we know that how many electrons are found in its valence shell. The metals generally have valence cells, means outermost cell. As we have already studied that the structure of atom, in that structure of atom we are knowing that atom is consist of a nucleus, and that nucleus is consist of neutron and proton, and that nucleus is surrounded by the shells, and that shells in which the electrons are continuously revolving in that shell, and the shell that is the outermost cell is commonly known as the valence cell, and in that shell the number of electrons that is found in that outermost cell is known as the valence electron. So we are just going to know about the electronic configuration of the metals. So in order to write the electronic configuration of the metals, we must know about that what is the atomic number of the element. For example, just I am going to give you one example of sodium. We must know about that. We must know that what is the atomic number of sodium. The atomic number of sodium is 11. So its electronic configuration is 2, 8, and 1. So its outermost cell contain one electron. Outermost cell contain one electron that it can easily lose, so that its octet becomes complete. So that electron that is present in its outermost cell, that is a one electron, that electron is known as a valence electron, and after losing that one electron it forms one positive ion. So that sodium becomes sodium ion. It becomes electropositive ion. So and we are knowing well that this is the property of the metal to form the electropositive ion, and the metals generally have 1, 2 or 3 electron in its outermost cell. So this is the example of the metal which have the 1 electron in its outermost cell. Next we just know about that magnesium. Magnesium is also one of the example of the metal, and its atomic number is 12, and its electronic configuration, if we will write, then it becomes 2, 8 and 2, means the third cell, that is the outermost cell, has the 2 electrons, and that shell is known as the valence cell. So its valence cell have the 2 electrons, so it can easily lose its 2 electrons, so that its octet becomes complete and it gains the 2 positive charge. So magnesium becomes magnesium ion, so it becomes electropositive ions, and there is a 2 positive charge on that. So by taking these two examples, we must know that the metals generally have 1, 2 or 3 electrons in its outermost cell, and they can easily lose that electrons to form the electropositive ions. Second is about the reaction with oxygen. Now we are going to know that when these metals react with oxygen, what is formed. So when the metals react with oxygen, generally the metal oxide is formed. We are knowing that when the oxygen is added to any metal, there is a formation of oxide. For example, when carbon reacts with oxygen, there is a formation of carbon dioxide. Just like metal react with oxygen, then there is a formation of metal oxide. And we must know about that what is the nature of that oxide that is formed after the reaction of the metal with oxygen. Now for example, we are going to take one example of magnesium, and we just conduct an experiment. In that experiment we will observe that at the last, that the nature of the oxide that is formed by this experiment, oxide that is formed, their nature is basic, means the metal oxide that is formed after the reaction of the metal with oxygen is basic in nature. For example, when you burn the magnesium ribbon, when you take a magnesium ribbon and burn it in a flame, then you will get a white color powder. That white color powder is mainly known as ash. That white color powder is mainly called what? That white color powder is the powder of the magnesium oxide. So that magnesium reacts with oxygen to form magnesium oxide, and that magnesium oxide, means that white powder, or we can say ash, when you mix it with water, you will just mix it properly, and when you check it you will get magnesium hydroxide. And when you check that with litmus paper, you will observe that when you put one drop of that solution on red litmus paper, it becomes blue. So this experiment shows that the nature of the oxide that is formed by this method, the nature of the oxide is what? Because it turns the red litmus paper into blue, so we can say that the nature of the oxide is basic in nature. So the metals generally form their metal oxide, and the nature of that oxide is it is basic in nature. Now there are certain examples given here. For example, one example that I have already told you about this: magnesium reacts with oxygen to form magnesium oxide. Just like sodium reacts with oxygen to form sodium oxide. Their formulas are given here. When the potassium reacts with oxygen, there is a formation of potassium oxide, and when the calcium reacts with oxygen, there is a formation of calcium oxide. And what is the nature of all these oxides? These all oxides are basic in nature. Next physical property of the metal is their reaction with water. Now we are going to know about that, the reaction of the metals with water. So when the metals react with water, there is a formation of metal oxide or metal hydroxide, plus hydrogen gas is also formed. So we can understand it by giving the following example. For example number metal. When these metals react with water, there is a formation of metal hydroxide or hydrogen gas is formed. When the metal reacts with water, there is a formation of metal oxide and the hydrogen gas is formed. So this is the reaction of the metals with the water. So when the metals react with water, there is formation of both metal hydroxide or metal oxide. And one of the most interesting features during this process, that a gas is released during this reaction, and that gas is known as the hydrogen gas. Now how we can check that the presence of the hydrogen gas? For example, just take one example. When you take one example, in that you are going to take magnesium. When that magnesium reacts with water to form magnesium hydroxide, and plus hydrogen gas is released, and if you want to determine the presence of the hydrogen gas, you bring a burning match stick near the test tube in which this reaction occurs. So that gas is released from that test tube. So when you take that burning matchstick near the mouth of the test tube, that gas burns with a pop sound. That pop sound indicates the presence of the hydrogen gas. So this pop sound indicates that the hydrogen gas is formed. So we can easily check it by this way. Next is the reaction of the metals with cold water. There are some metals which are very reactive. For example, sodium and potassium is one of the example of the very reactive metal. Calcium also. And one of the most interesting feature of that reactive metals is that they displace the hydrogen from the cold water at the room temperature and forming their hydroxide. For example, when the sodium reacts with water, there is formation of sodium hydroxide plus hydrogen gas is released. Next, the reaction of the metals with boiling water. Mainly the metals which are less reactive, they reacts with boiling water to form the oxides. For example, magnesium reacts with water to form magnesium oxide plus hydrogen gas is released. So the less reactive metal reacts with boiling water, whereas the more reactive metals such as sodium and potassium, they react with cold water. Next is about the reaction of the metals with steam. Other less reactive metals like iron and nickel, they have the property to displace the hydrogen gas from the steam. They displace the hydrogen gas from the steam, and forming only the oxides of metals, and here's only there is a formation of their oxides. For example, iron reacts with water, or we can say steam, to form iron oxide plus hydrogen gas is released. Next is reaction with the acids. Now we are going to know that when these metals react with acid, what is formed? Whenever the metal reacts with acid, there is a formation of salt and hydrogen gas is formed. So we are going to know that reaction with steam, that I have already told you. Now we are going to know about that reaction with acids. Now here, whenever a metal reacts with acid, there is a formation of the salt and a gas is released. That gas is the hydrogen gas. For example, when magnesium reacts with, the symbol of magnesium is Mg. When this magnesium reacts with hydrochloric acid, there is formation of magnesium chloride plus hydrogen gas is released. Next example is when zinc reacts with hydrochloric acid, there is formation of zinc chloride plus hydrogen gas is released. Next example is when magnesium reacts with sulfuric acid, the formula of sulfuric acid is H2SO4. There is a formation of magnesium sulfate, MgSO4 plus hydrogen gas is released. Next example is when zinc reacts with sulfuric acid, there is formation of zinc sulfate plus hydrogen gas is released. So this is about the reaction of the metals with the acid. So whenever the metal reacts with acid, there is formation of their salt plus hydrogen gas is released. Next is about the reaction with bases. Most of the metals do not react with bases, but there are only few metals like aluminum, zinc and lead that react with the solution of the strong bases like sodium hydroxide to produce the salt of that metal plus hydrogen gas is released. So this is about the reaction of the metals with the base. Next is about the metals physical and chemical properties. Just I have already told you about and we have discussed about the physical and chemical properties of the metals and non-metals. Now just remember all the points. Firstly, about the physical properties of the metals. Metals are malleable. Malleable means they can be beaten by its hammering. You can easily convert it into thin sheets or foil. So they are malleable. They are ductile means they can easily be drawn into wire. Next, metals are good conductor of heat and electricity means that allow the heat and electricity to pass through them very easily. They are sonorous means they produce a ringing sound when struck with a hard object, and they are generally found in solid state at room temperature, but there are some exceptional case also. For example, mercury is one of the example of the metal that is found in liquid state at the room temperature. Gallium is one of the example of the metal that is found in liquid state at the room temperature. Next, we have discussed about the chemical properties of the metals. The chemical properties means it is highly electropositive. Highly electropositive, that we can say that they have the tendency to lose the electron to form the electropositive ion. So I have already given you the example of the sodium, I have already given you the example of the magnesium, and I have told you that how the plus 1 positive charge is formed on sodium and plus 2 positive charges formed on magnesium. So they have generally 1, 2 or 3 valence electrons, so they can easily lose that electrons to form the electropositive ion. Second is metal react with water to form metal oxide plus metal hydroxide is formed, and metal reacts with oxygen to form the metal oxide, and the nature of that oxide is it is basic in nature. That I have given you the one example of the burning of magnesium ribbon. That magnesium ribbon burn in the presence of oxygen. When you burn it in the presence of oxygen, there is a formation of magnesium hydroxide, and when that magnesium hydroxide gets mixed with water, means that reaction of that metal oxide with water and formation of magnesium hydroxide. And we have checked the nature of the magnesium hydroxide, that it turns the red litmus paper into blue, so it is basic in nature. Next, the metal reacts with acid to form the salt plus hydrogen gases. The salt is formed plus hydrogen gas is released. Next is about that we have studied the reactivities of the metals to displace the less reactive metal. Now we will discuss about all these. We are going to discuss about this in part second of this chapter. So students, very soon we are going to come with the second part of this chapter. So I hope that you all have understood all the topics that we have covered today. Okay students, thank you.